And now, moving on to our next speaker, this is Microsoft Cathy Ye。下个阶段呢，我们请到的是 Microsoft Taiwan 的 Cathy Ye，她的职务呢是 Principal Group PM（Product Manager PM） of Corp R&D Team。所要探讨的题目呢是 EV Digital Twins Empowering Energy Agility。我们欢迎 Cathy Ye。Cathy, good afternoon.
Okay, good afternoon, everyone. Do you have a good day today?
Yes.
Okay. I know it's always hard to start from, the first one or two session in the afternoon because people, I know you guys are just having a very good break, lunch. So by the way, lunch is very good today, okay? So let me introduce myself a bit. My name is Cathy Ye, and I'm very, very pleased to represent Microsoft to join the MIH Automotive Seminar today. So today I'm going to talking about how to using the digital twin as a technology, especially to address the electronic vehicle and energy ecosystem issues, right? So can I back to my previous slide? Okay, all right. Okay, so I guess maybe it's just doing some like a time control, all right? So I just go ahead to kick off the presentation, right? So just in earlier session, Eric talking about the drive-by-wire, the SDK or the open platform. I think we want to embrace the open platform concept that's highlighted by MIH as a consortium, right? So, but today I'm going to switch the gear a bit because in my session I'm not going to touch more about the autonomous driving technology. But I want to also talk more about how to using the digital twin because digital twin could be applied into the whole electronic vehicle ecosystem. So in the matter of fact, I'm also seeing the digital twin has been applied into the autonomous driving area, especially for like simulation. So we all agree in terms of like vehicle innovation, the whole ecosystem is moving toward from standalone driving experience go to the e-mobility centric ecosystem, right? So we hear a lot of people talking about like a software-defined vehicle, right? But I don't know if any of you really think about what does that mean by software-defined vehicle, because that means the software need to across the board need to integrate from the hardware go to software, from the cloud go to the personal driving experience, and to provide more the e-mobility service, right? So along all those services, that's including ADAS, that's including charging service, that's including your personal entertainment service, because people are thinking about the EV electronic vehicle just like iPhone, but can, with the four wheel, right? So we can anticipate there's so many services will just around us while you are driving an electronic vehicle on the road, right? So it's starting from, just a standalone car, but go to more like e-transformation and smart city service, right? So what's the most critical, mission-critical service to differentiate traditional car and the electronic vehicle car? I believe all of us will agree the power. Power will be the most important things when we're thinking about the electronic vehicle. Yeah, so let's move to, if we want to really see, the energy agility will be, fully increased through the e-mobility service. And what will be the key pillar we need to think through while we are thinking about to having the better energy agility in electronic vehicle? There's basically three pillars. One is in vehicle itself. So we also need to thinking about how to build the connected car and the battery management system. So it's on the vehicle itself. Secondly, I think as a driver or as a passenger for the EV car, you don't want to worry about the range anxiety, right? So you want to ensure your power can support you go to elsewhere, go to anywhere, right? So how to assist driver to having the best charging service and don't worry about the distance, don't worry about the power consumption. I think that's the second part. And the third one, I think if you want to support you to having the best power consumption, the smart charging infrastructure will be the three pillar you also need to think about. So what's the capability we need to build up to support the three pillar? The first one is BMS. So I think you will see more and have more detail in the session later. So the battery management system that will play a very key part in the whole infrastructure. And secondly will be connected vehicle. Because the telemetry data or all the information you need to connect, not just from the BMS data, you also need to put together all the connected vehicle data and try to do some further analysis to really think about what would be the best behavior while you are driving the electronic vehicle. And the third one will be the charging platform. And of course, people are talking about how to leverage the vehicle as a distributed grid to help you to do the, the better power grid, the management, right? So B2G and the B2H will be another capability. We are seeing a lot of like energy company and also the CPO are, looking forward. And the last one will be the virtual power plant, right? So if we look at that, currently we are working with the MIH on doing a work group regarding the energy. Those the 4-5 capability are basically will be the major task force we want to drive in the MIH working group. To support those the capability, Microsoft, we are the technology company, so basically it need to be supported by what's the device management technology, IoT and machine learning, and of course, digital twin. That's the technology I'm going to highlight and further deep dive today. And AI cognitive service, and the last but not least, communication technology like satellites and mapping. And we have the friend from TomTom. I think they also play a very important role while it's go to like a geospatial mapping, road condition related information. Okay, so let's further look into the persona and the use case we are having, right? So basically, there is 4 key elements while we are thinking about the electronic vehicle. 4 elements. The first element, of course, driver or the citizen, right? So what's the use case we may need to address while we are thinking about from the driver or citizen perspective? I think as a driver, you need to do a planned charging schedule. Where should I charge? When should I charge? What's the best timing for myself to really driving my car, go to a charging station and to have the best deal? But in the same time, I don't want to worry about the range. I don't want to have the range anxiety. And as an EV manufacturer, you are the one who build the who build the electronic vehicle. So how will other vehicle systems to impact the battery performance? How can I build a better performance battery system, but come together with the whole of the electronic vehicle? And the third one will be the charging operator. Sometimes we call that CPO or MPO, right? So as a charging operator, basically, you charge the driver. You charge the driver because they charge their the electronic vehicle in your charging station. But in the same time, you need to pay Taiwan. You need to pay the utility company. You need to sign a contract with the utility company, right? So basically, your goal is you want to increase the utilization. You want to increase your consumer loyalty. But in the same time, you want to have the better deal with the Taiwan, with the utility company. And the fourth part is actually a very important part, is the utility company, right? So I think the fundamental goal for the utility company, especially for like a utility company like a Taiwan, they are the only one in Taiwan, right? So I think the ultimate goal for them is they are worried about the increasing electronic vehicle could be the burden for the power grid in Taiwan, right? So how can they turn the EV car from the burden go to the asset? That could be the EV infrastructure, the EV grid, could be another ancillary service for the power grid in Taiwan. So those are 4 pillars we need to think about when we are thinking about to apply the digital twin into the whole EV grid. So the idea here is we need to create a so-called digital feedback loop. So starting the 4 elements, drivers, vehicle battery, charging infrastructure, and utility. So when we're thinking about the digital feedback loop, it shouldn't be just one way, just collect the data. We need to in return, because the beauty of the digital twin is create a digital feedback loop. Let's make the driver who can enjoy the better service, who can have the best deal. Let's enable the vehicle manufacturer. They can get the data, no matter from the charging infrastructure or the driver, to build a better performance battery or to build a better EV car. Let's allow the utility company who can really turn the EV from burden go to the asset. Okay, so that's the concept. So let's further deep dive into what exactly the digital twin can do. When people are thinking about, yeah, I want to build a software-defined manufacturer, that means you need to digitize everything in your EV car. In traditional car, it might be hard, but in the electronic vehicle car, I would say it's much more possible, because you are able to collect as much as the information, because you has been electronified, all those components, right? So when we look into the digital twin capability, what exactly the capability we need to gain from the digital twin? Basically, you will need to digitalize everything. So you got your physical world, but you also need to build your virtual world. So with the digital twin capability, you need to be able to synchronize what happened now, what happened in the past, and to predict what will be happen in the future, right? So the fundamental part to digitalize everything is you need to know how to model the object, how to model the relationship, how to model the behavior will happen, right? So I would say model object could be easy, because you can just build a property. You can put the number to relate it to the property, but it's always hard to model the behavior and the relationship. Because in real world, the relationship could be very complex. It's not just putting in the hierarchy infrastructure or hierarchy structure. Basically, it could be interlocked very complexly, right? So having the right model to really structure the whole object is very fundamental to the digital twin. So with the digital twin, you will be able to monitor and to track the past, and also, I think that fundamentally, you want to do a better prediction and allows you to able to simulate what if situation. Okay, so if we have some logical view about the digital twin, basically, you have the input. You need to acquire, you need to get the data from the different source. So the source, in our case, in the energy case, the source could be coming from driver, the driver behavior, and the deal driver want to purchase. And the data could be from the BMS, the battery management system, or the vehicle telemetry data. And also, you also need to get the data from the charging station, the charging infrastructure, and the utility company. But it's not enough. You just collect all the data put together. The most important thing is that will help you to have the business intelligence to support you to visualize what's happening, to do the prediction, to do the further analysis, and of course, the most important is feedback and trigger you to take the right action to your vehicle or your charging behavior. Okay, so this diagram is a very busy diagram, but I want to just call out the effort currently we are putting together within the MIH working group, right? So if we look into the EV grid value chain, basically you have the vehicle, you have the cell phone that's held by consumer and the driver. They use the cell phone to find the best way, to find the best place to do the charging. And you have the charging station, and basically all the ecosystem, all the elements, they exchange the data, they trigger the applications through the cloud. And of course, you need to support by the utility company. You need to plug into the grid as a microgrid infrastructure, right? So there is so many data exchange in the whole ecosystem. You have the in-vehicle data, so basically the most of the automotive electronic are supporting CAN as a protocol, right? You also need to get data from the user information. And also we are seeing there's so many data exchanges through the vehicle to cloud, vehicle to charging station, and charging station to cloud, and of course, grid to charging station. So one of the effort we are putting together in MIH working group is, can we having the standard format when it's come to like a data exchange? Okay, so why we need to make things so complex? Because when people are thinking about, yeah, I know digital twin could be very powerful, right? But why we need to, really accommodate that many layer data? That's mainly because we always ask a very complex question. The complex question may be across the board. It's not just about the battery itself. It's not just about the driver itself. Because we always ask the question is, okay, so right now in Taiwan, it's super hot, right? 30 Celsius degree, right? So people may thinking about, so how did the temperature on the road to impact the battery consumption in the different season, right? Maybe you're driving in the winter time in Taiwan, and your power consumption may be, consumed, slower. But thinking about you are driving in the Nordic country, right? Super cool, super cold temperature. So how does that impact to your power consumption, right? So people having that question, because that's also very important while you want to ship your car, go to a different country, or you want to ship your battery module, go to a different country. So that's meaning maybe that question may be related to the car manufacturer. But as a driver, you probably want to know, maybe weekend is coming, today is Friday, right? You may plan to go to like Ali Mountain or Yangming Mountain to drive your electronic vehicle, right? So you probably can thinking about, so I know go to mountain, there's a lot of like long haul uphill driving. So how does that impact my power consumption during the holiday, last holiday? So you may have that question in your mind, right? And as a charging station operator, last week, maybe you set up the charging station just nearby arena, right? So there is a big show coming, there is a big game coming, right? So you want to really think about how did the power demand change for the EV charging station that's nearby the arena during the summer, the Saturday game, right? Because you need to prepare. You don't want your customer to waiting in a line, just waiting for a charging. You want to do a better job to really allocate all the charging station. And if the V2G is available in the market, and how does the V2G will help the government or help the Thai power to reduce the disruption, right? So those are the very complex questions that will be happen in the whole EV grid infrastructure, right? So the reason why we want to build the so-called twin graph is because we know the problem will be very complex. So we need to have the better visibility. We need to have the better simulation tool to help you to address all those complex questions. So here is the digital twin graph explorer. So with the tool, that allows you to really have the better understanding about what's your relationship between your different components. And you can also even integrate with your simulation tool and to ask the what if question. Okay, so people may think about, wow, it's still a technology, maybe aspirational, but in a matter of fact, it's already happened, right? So, for example, like Hyundai Motor, the tier 1 Korean automotive company, in the matter of fact, they have already applied digital twin as a pilot project, help them to improve the EV battery performance. So the data source, they take some data from the BMS system. They also take data from their driver behavior and also road condition. So they found out, I think maybe people already know that slower charging may, really help to increase the lifespan of the battery. Or if you drive the car in more moderate way, that may also help for you to really increase your lifespan of the battery, right? So it's just a pilot project, but we are looking forward is, can we maybe have more data source? I mean, to having more digital twin as the real-time data source help you to maybe incorporate more road condition, or in the future, maybe that can accommodate more like, mapping information or road condition information. Let's help you to do a better job to predict the battery consumption. Or even though people are thinking about maybe battery can get into the second-hand market, right? So how can you estimate the price or the value of the battery? So you also need to have the model to really to estimate what's the lifespan for your battery. So the other use case is actually happening in Taiwan. So we're also working with MIH and also some of the partners like ES Energy last year, so to build the so-called the V2G, the vehicle to grid pilot last year, right? So the pilot here is we want to demonstrate, the electronic vehicle car is not just consume the car. In a matter of fact, it can return back some power back to the grid, back to Taipower, right? So a very positive quote from Taipower is, even though they anticipate the EV car will picking up very soon, right? But they also want to see there is an opportunity for the electronic vehicle to be the distributed grid, and that can be ancillary service for the Taipower, and they can increase the resilience and also, more like the power supply in near future. Okay, so that's also another pilot or maybe a project we can think about as MIH member. We also want to working with the broader partner in the ecosystem and try to build more application. Okay. So this is my last slide, but I just want to, using the slide to close my talk today. So we know there's many more applications coming up, especially in the grid or the energy-related application in the electronic vehicle, right? So the effort we want to put together with the MIH working group here is we're starting from to set up the data exchange standard. That's across the board, from driver go to vehicle or even to cloud and the grid. And that will be used to support the different application. That's including BMS system, connected vehicle, charging platform. So as a consortium, I think we are responsible, or we should facilitate that kind of platform to encourage our member and our partner to develop more reference architecture or reference implementation. So what we are working now is for the different application, it needs to have the reference architecture to help our member, to help our partner to really think about what would be the best way, what would be the more open way to develop your application. But in between, I want to highlight here is you shouldn't just take the raw data and try to build an application. It's very important if you can have the so-called contextualization data platform for you to develop all those applications. So what I put inside here is the twin graph or the digital twin platform will allow you to really reduce the effort while you are building up the application. But in the same time, you also need to have the knowledge. So that's why we are seeing some of the ISV or the new sub companies start to devote themselves into like a knowledge graph. So the knowledge graph allows you to have the deep understanding about the vehicle structure, about the BMS system, the battery structure. But in the other side, when it's come to like grid management, we are also building the intelligent forecast module and the intelligent energy trading module. Let's help those applications or the service provider. They can, just using those API to build their own application. right? Okay, so basically, I would say it's an evolving technology, and we are just in the starting of the journey, right? So, very looking forward to a partnership with all of you, and let's drive for more like agility for the whole EV infrastructure, right? Thank you for your listening.
Thank you very much to Madame Cathy Ye. Wonderful presentation. Yes, the journey is just beginning, and we shall all travel together. Very important, EV Digital Twins platform, very important for building applications.